Okay, next I want to talk about tangent plane. This one can get a little tricky, so I am going to try and slow down a little bit on it. And we're going to do a couple of examples of it, and hopefully it's good enough for it to sink in. So let's first talk about the equation of a tangent plane. So we've got, for a tangent plane, we're going to use our normal vector dotted with some positional vector that we are going to create. And we were going to make that equal 0. Now, if we remember the way the dot product works, which there's a video on this too if you don't remember, and it's okay, the dot product tells you the angle between two vectors using cosine. Cosine is equal to 0 at 90 degrees. So that's telling us that we're going to make sure that this is a normal vector of this positional vector by setting this all equal to 0. So what we can do here is we can actually take this and break it out into the full dot product form, which is going to look something like this, where a, b, and c are just constants that we're going to have to solve for. Okay, and again, like always, I'm kind of expecting you guys to have already covered this in your class, and I'm just kind of breezing through the explanation so we can get to the examples. So there's a few things. So we're going to try and manipulate this. To get c equal to -1, okay? And then once you do that, you're going to have all of the stuff in front's going to be the same, but you're going to get plus z sub 0 equals to z. But then the next thing you're going to do is you're going to do two things separately. You're going to let y equal y0, and then you're also going to let x equal x0 separately from this manipulated equation. So then that'll give you something like a equals partial derivative of f of x, where x sub 0 and y sub 0, right? Because I guess I'll write the step before that as well. So this is what we're looking for here. So we have a times just the difference in x and x naught plus some initial height and z. This is just the point slope of a linear equation. So we know that that means a is just going to be this partial of x. And then using the same logic over here, we're going to get b y sub 0, plus z sub 0 equals z. Okay, and so then we're going to have b is equal to the partial with respect to y with our x sub naught and our y sub 0. Okay, now if we plug all of that back into our original formula, we're going to get something kind of like this. We have f partial of x, where we're plugging in x sub 0 and y sub 0, and that's going to be multiplied by x minus x sub 0. And then we're going to add that to the partial of y, plugging in our initial point. And we're going to multiply that by y minus y sub 0. Then we're going to add our z sub 0, and all of that is going to be equal to z, which this is kind of what we want. We're using z as our tangent plane. Okay. So now what we can do is we can actually go through and just, push through a couple of these. That is our formula we're going to be going for here. So if we're given f of x is equal to 2 minus x squared minus y squared, and we're given a point P, which is 1/2 comma 1/2, setting this up is really straightforward. So the first thing we're going to do is solve for z sub 0. So we're just going to plug this point into our original equation, right? So z sub 0 is just f evaluated at these points. So we've got 2 minus 1 over 2 squared minus 1 over 2 squared, right? And so then that gives us z sub 0 is equal to 2 minus 1 over 4. Minus 1 over 4 is minus 1/2, so we get 3 over 2. Nice and easy. Okay, so we've already got our z sub 0. So next thing we can do is we can take our partial derivative with respect to x, and that's of this whole function. So 2 partial derivative of x is 0, so we get negative 2x for the next one. There's no x's here, so that's just 0. So our partial derivative with respect to x is just negative 2x. Okay, and then we're going to take our partial derivative with respect to y, and we're going to get the same thing, except for it's 2y instead of 2x. And then our next thing is just to plug in our point here. So we're going to plug in this 1 over 2 over 1 over 2. Okay, And so we're going to get negative 2 times 1 over 2. Don't like the way that 2 came out, so give me just a second to clean that up. Okay, that's a little better, which in this case is just negative 1. And then we're going to do the same thing here with our f sub y. So we're going to get negative 2 again times 1 over 2, which is still going to be negative 1. Okay, and now we have everything we need to plug into our equation. So we've got f of x, where we plugged in our point, is negative 1. So we have negative 1 times x minus, now x sub 0 we have, it's 1/2. Okay, and then we have plus f partial derivative of y is negative 1. And then that's times our y minus y sub 0. And then we have plus our z sub 0 is 3/2. Wow, that did not work at all. 3/2, there we go. And all of that equals z, right? And so now we'll just do a quick little algebraic simplification here. So we get negative x, positive 1/2, and then minus y plus 1/2 plus 3/2 equals z. Okay, so then z is equal to negative x, negative y, plus 5 over 2.